In this slide, we're going to solve a polynomial systems problem, which is very well suited for a long exam. Let's read the problem. A field is enclosed by a wall AH and fencing at the rest of the boundary as depicted. So here's the picture of our problem. Here's the picture. We're having a field which looks like two rectangles pasted next to one another. We're also given that this segment here, AH, this is the point A, this is the point H. So this segment AH corresponds to a wall. So this segment here, the thicker segment, is a wall. Here we're having a wall. And the remaining part of the enclosure is a fence, so built of a different material. So this is the fence. Okay, what are we also given? We're given that this distance, EF, is the same as the distance AH. So the two distances are the same, and they are equal to 20 meters. We're also given that this distance here, BC, is equal to Y. Y is not given, so Y is an unknown. We're also given that this distance here, AB, is the same as this is the distance here, CD. That follows simply from the fact that you're having two rectangles. And that distance is equal to 2x. We're also given that the distance here, DE, which by the way must be equal to the distance GF that we see here. So that distance is 3x. Here the same variable x that we used for this distance. Okay, what else are we given? We're given that the length of the fence, so the length of the fence, this is the fence here, so the length of the fence, excluding the wall, is 130 meters. We're also given that the area of rectangle HBCG, H, that's this point, B, that's that point, C, there we are, G. So the area of this rectangle we're given is 3 times the area of that other rectangle. So the area of the big rectangle is 3 times the area of D, E, F, G. Rectangle DEFG. So the small rectangle has 1/3 of the area of the large rectangle. Let's find the length of the segment HF. So we're looking for the length of this segment, segment HF. We're seeking to find the length of this segment. This is HF. All right. As I was reading the problem, I was taking notes. So I noted that the fence has length 130 meters. I also wrote down that the area of the large rectangle is 3 times the area of the small rectangle. So when we solve text problems, it is very important to extract formulas from the text as we read the text. Now, let's compute the length of our fence. The length of our fence, I claim, is given by this expression. So let's see why the length of the fence is that long expression. Let's see where the expression comes from. Well, the length of the expression is certainly, the length of the fence is certainly equal to the length of this segment here, and plus the length of that segment. And these two segments, they are equal and they are of length y. So I'm having 2y contributed by these two sections of the fence. I'm also having that this section of the fence and that section of the fence contribute 2 times 2x length. I'm also having that these two sections of the fence each contributes 3x, so both of them contribute 2 times 3x. And finally, I have the final section of the fence, EF, which it was given to us was equal to 20 meters. So I'm given that 2y plus 2 times 2x plus 2 times 3x plus 20 equals 130. I've dropped here the measurement units. Okay. Now let's simplify a little bit. 2 times 2x plus 2 times 3x, that is 4x plus 6x, which is 10x. So this is 4x, this is 6x, so we altogether get 10x. Okay. I have transferred 20 on the other side, and of course 130 minus 20 is 110. Okay, next, let me notice that the two sides of this equality are both divisible by 2. So in order to simplify my equality, I'm going to divide both sides by 2. So 10 divided by 2 is 5, 2 divided by 2 is 1, and 110 divided by 2 is 55. So I have simplified my equality a little bit. Now, we're having two variables in the game, x and y. Let's try to eliminate one of the variables. What can we do? Well, see, as you can see, I can take this 5x and transfer it to the right-hand side. Of course, when I transfer 5x to the right-hand side, it acquires a minus. And why is that beneficial? Well, in this way, I have expressed y as a function of x. And so I can now eliminate the variable y. I no longer need the variable y. That's very good. Now my problem involves only a single variable, the variable x. I still haven't used at all this part of the given information. So so let's now take advantage of that additional information. Now, the area of rectangle HBCG, what's that equal to? Well, this is a rectangle, so its area is equal to its width times its height. And the width of the rectangle, that happens to be y units, that's my width. And the height of that rectangle is, well, it's this height here. And I can see that the height of my rectangle, well, the height of my rectangle, so the height of my rectangle is this distance here. And that's 20 plus 2x. So the height of my rectangle is 20 plus 2x. Okay, so this is my rectangle, the width, here's the height. And now let's take a look at a rectangle DEFG. The area of that rectangle is again equal to its width. This is the width of the rectangle. It's the width. Times its height. So that's the height of my rectangle. Here it is. Height. All right. So now we have expressed the second part of the conditions of the problem into a formula. Now, let's see whether we can solve the resulting polynomial system. Right, so far we have generated a polynomial system consisting of two equalities. The first equality is y equal to 55 minus 5x, so that's the equation number 1. And the equation number 2 is y times 2x plus 20 equal 3 times 3x plus 20. So that is a polynomial system. Polynomial system in two variables, namely the variable y and x, and with two equations, these two. All right, so how do I solve this system? Well, it is fairly clear that I can transform this to a system, to a single equation of a single variable by simply substituting y with 55 minus 5x. So I can take y and replace it with 55 minus 5x, and that equation is now, so my polynomial system has now been transformed to a single equation. Okay, so let's solve that equation. I know that I can solve that equation, but because it's quadratic. As you can see, the highest order term on this side is 5x times 2x, so this is a quadratic equation. Yes, I have done one more thing besides replacing y with 55 minus 5x. I have taken this term and I have transferred it on the other side. And it seems that I have simplified this term into 180x. Is that the case? Well, let's see. 3 times 3x times 20 is equal to 9 times x times 20, which is equal to 9 times 20. That gives me 180. So 180x. So on this side, I'm having 180x. And when I transfer it to the left-hand side, it acquires a minus. All right. Now, let's distribute the parentheses here. So let's uncover all the parentheses. So 55 times 2x gives me 110x. 55 times 20, well, 55 times 2 is 110, and times another 10, that's 1,100. Negative 5x times 2x, well, that is negative 10x squared. And finally, 5x times 20 is, well, 5 times 20 is 100, so minus 100x. And I have also copied minus 180x. Okay, we can combine some terms. Let's see. Here I'm having 110x minus 100x, that gives me 10x. And 10x minus, so from these two I'm getting 10x. And from 10x, when I subtract 180x, I get minus 170x. So that's how I got my minus 170x. I've also copied 1,100 and negative 10x. Now, as you can see, I run out of space. So, when you're solving this problem by pen and paper, you can just use more pages. This is quite a long problem. So now, because I run out of space, I'm going to have to remove part of the formulas. So I'm going to take the two highlighted formulas that you see there. I'm going to move them up, and I'm going to erase some of the remaining formulas. So let me do that. There we go. So I've just copied what is most relevant. I've copied the relationship y equals 55 minus 5x. That, if you remember, came from the fencing perimeter. And I've also copied the other relation, which came through combining the first relation with the relationship between the areas of the two rectangles. Okay, so now let us solve this equation. Let us solve the equation negative 10x squared minus 170x plus 1,100 equal to 0. Now this is a quadratic equation, and I can solve it directly with the quadratic formula. But before I do that, let me notice that both sides of this equality are divisible by 10. So let me divide, actually by negative 10. So let me divide both sides by negative 10. So when I divide both sides of an equality by a negative number, I make all minuses into pluses and all pluses into minuses. And of course, when I multiply 0 by negative 1, it remains 0. And when I divide by 10, I'm just eliminating 1 0 from each of these terms. So I'm left with x squared plus 17x minus 110. Okay, so now I'm ready to apply the quadratic formula. Okay, so now let's see how we're going to do this. We could either try to guess the solution, the factorization of this quadratic, or we could try to use the quadratic formula. Which one should we use? Let's first try guessing. So whatever numbers I should put there, their sum must be 17, and their product must be minus 110, right? Because when I distribute the parentheses, their sum will turn out to be 17, and their product will be, well, minus 110. So let's see, 110 is equal to 11 times 10, which is 11 times 2 times 5. Can we somehow group these into two groups? So I think I could write this as 22 times 5. So if I take minus 110, I could rewrite that as 22 times negative 5. And it seems to me that if I take 22 plus negative 5, that's going to be exactly equal to 17, I think. So I think that in my factorization, the numbers should be negative 5 and 22. Did I guess that correctly? Did you guess that correctly? Yes. X minus 5 times x plus 22. Now, I just showed you how to quickly guess the factorization of this quadratic, but what I did use is I use a lot of intuition, and not everybody is comfortable with quickly playing with numbers, and after all, you may not be as lucky as to try a good guess very, very quickly. So instead of trying to guess a factorization, we may just use the quadratic formula. So let's do that as well, just for exercise. So let's try to solve this quadratic using the quadratic formula. So let's solve that quadratic using the quadratic formula. Okay, so the two solutions of this quadratic equation, so I'm solving. So the two solutions are x1 and x2. They are given by negative b plus or minus radical of b squared minus 4ac over 2a. So, negative 17 plus or minus radical of 17 squared minus 4 times 1 times minus 110, the whole thing divided by 2. Alright, so we get minus 17 plus or minus radical of, now 17 squared, that is 289, minus with minus gives me plus 440. Now, how did I compute that 17 squared is equal to 289? I simply have that memorized. I highly recommend memorizing the squares for the practical purpose of problem solving quickly. But if we have not memorized 17 squared, we can quickly compute it on the side in the usual way. So 17 times 17 equals 7 times 7 is 49, 9, carry over 4. 7 times 1 is 7, and 4, that gives me 11. And then 1, 7 there. And when I add the 2, I get 9, 8, 2. Okay, so 17 times 17 is 289. Okay, and here I'm still dividing by 2. So I'm getting negative 17 plus or minus radical of 289 and 440. That gives me 600. So 289 plus 440 gives me 200 plus 400 plus 89 plus 40, right? So these two are from 289 and those two are from 440. So that altogether gives me 600 plus 129, so I'm getting 729. So that gives me 729. Radical of 729 over 2. Let me erase these intermediate computations here so that we do not get disturbed. Okay, now it would be fantastic if 729 is a perfect square. Now I happen to know that that's a perfect square, but it's 27 square. But if we don't have that memorized, we should try quickly with the squares above 20. We should quickly try to run the squares through our head and hope that one of the squares is 729. So I'm just going to try to convince you that 27 squared is equal to 729. Once again, I have that memorized, but if you don't, here's what you can do. You can take 27 times 27. 7 times 7 equals 49 and carry over 4. 7 times 2 is 14 plus 4, that is 18. 2 times 7 is 14, 4 and carry over 1. 2 times 2 is 4 plus carry over 1, that is 5. And when we add the 2, we're getting 9. 8 plus 4 is 12, 2 carry over 1. 1 plus 5 is 6 and carry over 1, that is 7. So 729. So indeed 27 squared equals 729. How did I know to guess that 27 squared equals 729 and not say 30 squared or 28 squared? Well, see, 27 squared, its last digit is going to be the same as the last digit of 7 squared. And since 7 squared is 49, I know that, so since 7 squared is 49, I know that the last digit of 27 squared is going to be 9. So I know that if 729 is to be a perfect square, I know that it would be expected that it is a square of a number which ends on 7, or maybe a square of a number which ends on 3. And I know that 27 squared is approximately between 600 and 800. So I tried first with 27 squared. Of course, it could also happen that whatever number we got here is not a perfect square. If that is to happen, then we cannot truly simplify this much. But here, in this particular problem, we got very lucky that we got a perfect square. So we got a perfect square by luck. Well, of course, not by luck, but by the virtue of the people who designed the problem selecting an easy problem, easy numbers. Okay. So we are getting negative 17 plus or minus radical of 27 squared over 2. So we're getting negative 17 plus or minus 27 over 2, which gives me negative 17 plus 27 over 2, which gives me 10 over 2, which gives me 5. Or 17 plus 27 over 2, which gives me 17 and 27, that is 44 over 2, which gives me 22. Whoops. This is minus 17 minus 27. So minus 17 minus 27, so that is minus 44, so that is negative 22. So I'm getting negative 22, which means that my polynomial factors as x minus x1 times x minus x2. This is here is x1, this here is x2. So my polynomial factors as x minus 5 times x minus 22, which gives me x minus 5 times x plus 22, exactly what I guessed to begin with. So you can see that I can factor my quadratic. So once again, to recap, so I'm going to erase these computations. You can pause the video if you're tracking them. But to recap everything, let me erase the computation. To recap, either use the quadratic formula here, or if you're skillful and love tricks, you can try to guess the factorization. I showed you both approaches. Okay, so we have now solved our quadratic equation. We're getting that x is equal to 5 or x is equal to negative 22. Okay. Now, x cannot be equal to negative 22 because x is a positive quantity. That's not given anywhere in the problem. So nowhere does the problem say that x is greater than 0. But what we're given is that x denotes length. So x stands for length. So x is a length. It's a physical length. It's a length of a physical object. So that implies that x is positive. Once again, I'm using here common sense and the statement of the problem. Okay. So now let's see. Y was given to be 55 minus 5x. And I just found out what x was. X is 5. So y must be 55 minus 5 times 5, which is 55 minus 25, which is 30. So this is 25 here. So 55 minus 25 is 30. All right. Okay. So I'm almost done. The only thing that remains for me to finish this problem is to actually complete the problem. The problem asked me to find the length of HF, so I needed to find this length here. And the length of HF is equal to, well, it's equal to y plus 3x. Right, so this length here is y. This length and that length are the same, and this length there is 3x. So my length, the length that I was looking for is y plus 3x, and I know what y and x are, so I'm essentially done. Y we found it to be 30. X we found it to be 5. Now I'm getting 30 plus 15, this is 15, which is 45. So 30 plus 15 is 45, and my solution is complete. I have found the length HF. This completes the problem.